folks. Welcome to
Vector Calculus.
Oh, you caught me off guard there. How do you actually find the distance between points in three-dimensional space? That's the question we're going to address today. Let's go ahead and check it out with an example. First, we're going to start with two-dimensional space. So let's say you have 2 points, 1, 2, and 3, 4. Let's keep things simple. How do you find the distance between these 2 points? Well, hopefully you remember from your algebra class, we can designate each of the x coordinates as x1 and x2, and we can designate each of the y coordinates as y1 and y2. And now we can simply use the Pythagorean theorem. And what does the Pythagorean theorem tell us? It tells us that the distance between these 2 points, which I'll call d, the distance between these 2 points is going to be what? It's going to be the square of the difference in the x coordinates, x2 minus x1 whole squared, plus the square of the difference in the y coordinates, which is going to be what? It's going to be y2 minus y1 squared. And what's the reasoning behind this? What's the rationale behind this? Well, the rationale behind this is if you come over to the xy axis, okay, what you're going to have is 2 points, right? 1, 2 is somewhere here. 3, 4 is somewhere here. Each of these has an x and y coordinate, right? So for example, this one, we call it x1. This one, we call it x2. This one over here, x1 is also has y1. This one also has y2. So each of these points has 2 coordinates, right? And we want to find the distance between these points, right? We call that distance d over here, for example. And how do you find this distance, this purple distance over here? How do you find how big this distance is? Well, you might know to use the Pythagorean theorem. What does the Pythagorean theorem tell you? Well, it says make a right triangle. Make a right triangle. So if you make a right triangle, what's the length of this side? Well, hey, it's going to be the difference in the x coordinates. So that's going to be x2 minus x1. And hey, what's the length of this side? Well, this side over here, that's going to be the difference in the y coordinates. In other words, y2 minus y1. And so what's my total distance between these 2 points going to be? Well, it's going to be given by the Pythagorean theorem, right? The square of this side plus the square of this side, square root them. So you're going to have what? You're going to have the square root of, well, in this case, we can actually plug in the points. What are my points? What's x2? Well, it's 3. My x2 is going to be 3. What's x1? It's going to be 1. And then we can do the same principle with our y coordinates, right? So what's our y2? It's going to be 4. So let's go ahead and write that down. 4 minus what's my y coordinate? y1, 2. And now I can just simplify this, right? So what is this going to become in the square root? I'm going to have 3 minus 1 squared, which is 4. And 4 minus 2 squared, which is also 4. In other words, I'll end up with what? I'll end up with the square root of 8. And that's the distance between these 2 points. The distance between these 2 points is the square root of 8. Now that's in how many dimensions? Well, that's in 2 dimensions. So we now know how to find distance in 2 dimensions. But here's a critical question. How can we extend this to 3 dimensions? In other words, how can we find the distance between any 2 points in 3D space? Now, if this seems very abstract, don't worry. We're going to visualize it in just a sec. Because this is something that's really easy to visualize, actually. If I give you 2 points, let's say here and here. How do you find the distance between my 2 fists? My 2 points, if you want to imagine it that way. So how do you find this distance? Well, that's what today is all about. How do you find the distance between 2 points in 3D space? Let's go ahead, check it out. So what we're going to start with is, let me get a black marker here. So what we're going to start with is, of course, the 3-dimensional coordinate plane. So I'm going to have my z-axis, my y-axis, and my x-axis. I don't know about left-handed, right-handed coordinate systems. I don't really care much about that. But here's my axis, right? Here's my x, here's my y, here's my z. Hopefully that clears things up. I'll put some arrows over here So you know that these are indeed our axes. Now, what are we going to do? Well, we're going to get some points in here, right? We want to find the distance between 2 points. So let's put some points down. Let me see if we have brown over here. If we do, that's going to be great. So we can visualize this. So here we go. Let's say I have 2 points. So one, okay, of course. So here's my first point, let's say. Just an arbitrary point, and here's my second point. So let me give this point a value, right? Without values, it really has no meaning. Let's say it's at 1, 2, 3. What does that mean, though? Well, let me show you what it means. What that means is this 1 over here is my x coordinate. It tells me I have to go 1 in this direction to reach my point. This y over here, this 2 over here, that's my y coordinate. It tells me I have to go 2 units up, 1, 2 units up to get to my point. And finally, oh, I'm sorry. Yeah, sorry about that. The y-axis actually goes that way. So let's go that way. So I have to go 2 units this way, 1 unit, 2 unit, and finally I have to go 3 units in the z direction to reach my point. 3 units in the z direction to reach my point. So let's go up 1 unit, 2 unit, and 3 unit. And how embarrassing is that? My point is actually over here. But nonetheless, you get the point. 1, 2, 3. My x, y, and z axes, my x, y, and z coordinates each tell me how far I should be from each one of the axes. So hopefully that makes sense for you. I'm going to recap it once again if you don't understand. Okay, this 1 over here tells me that I have to go 1 unit in the x direction, in the x-axis. This 2 over here is my y coordinate. It tells me I have to go 2 units in the y direction. This 3 over here tells me I should go 3 units in the z direction. And that's where my point is. Okay, good. Okay, now let's say I have another point here. Let's see what that point will be. Let's see how many steps it takes to get to that point. I need to go 1 step in the x, 1 step in the y. So let's keep things color coded. So I'm gonna go 1 step in the y, another step in the y, another step, another step, another step, and another step. So how many steps have I got in the y? I've got 1, 2, 3, 4, 5, 6 steps in the y. Let's see how many steps in the x direction I need. So I'm gonna need, for example, I'm just eyeballing it here. I'm gonna need, for instance, 1 step in the x, 2 steps in the x, and just to jazz things up a bit, let's say I need 1 step in the z direction. So that right there is my second point. And as you just saw, I need 3 coordinates once again. I took how many steps in the y direction? If you remember, I took 6 steps. 1, 2, 3, 4, 5, 6 steps in the y direction. So that's my y coordinate over here. How many steps did I take in my x direction? 1, 2. So that's going to be 2 steps in my x direction. So my x coordinate will be 2. And finally, how many steps did I take in my z direction? I took only 1 step, so my z coordinate is just going to be 1. Now, how do I find the distance between these 2 points? Well, let's get started. All we have to do really is first thing you want to do is connect your points. It's as basic as that. That's what we're trying to get at. How big is this line? How big is that green line? That's what we're really trying to figure out. How big is that distance? Now to find that distance, once again, we're going to use the Pythagorean Theorem. And actually this time we're going to be using the 3-dimensional Pythagorean Theorem. And that Pythagorean Theorem is going to tell us the distance between these 2 lines. These 2 points. Let's call that distance d like we did before. So that distance is, hopefully you can imagine, it's going to be the difference in the x coordinates. So it's going to be x2 minus x1 once again. So for example, let's call this x2 and this x1. It's going to be the difference in the y coordinates. So it's going to be y2 minus y1. So this is y2, this is y1. It's going to be the difference in the z coordinates. This is going to be z2, z1, z2, z1. And don't forget, you have to square each one of these terms. You have to square this difference. You have to square that difference. And finally, you have to square this x coordinate difference. And last thing we want to do is go ahead and add all three of these terms up. Okay, now given that information, how can we apply it here? Well, we can just go ahead and plug in the points, right? What's my x2 over here? My x2 is 2, so I can go ahead and just write down 2, right? So 2 minus, what's my x1? That's 1. Okay, good. Let's do the same principle with my y coordinates. What's my y2? It's going to be 6. So let's go ahead and keep things color coded. So I'm going to have 6 minus y1. y1 of course is 2, and I'm going to square that. Finally, I'm going to be left over with my z coordinates. What's my z coordinates? My z2 is of course 1, as you can see over here. So let's go ahead and write that down. 1 minus what? 3. That's my z1, 3. And so now we can just simplify this, pretty easy, not too bad. So we're going to be left over with what? Well, 2 minus 1 squared is just 1 squared. 6 minus 2 squared is just 4 squared. And 1 minus 3 squared is just negative 2 squared. So what's that going to be? Well, that's going to be square root of 17. Is that right? Let's check. 16 plus 4, of course I got it wrong. 16 plus 4 plus 1 is going to give us square root of 21 as the final distance. So this distance over here between our 2 points in 3D is going to be square root of 21 units. And that's how you find the distance between 2 points in 3-dimensional space. Thanks for watching this lecture on vector calculus. We'll check you out next time.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.